Welcome to our deep dive into the intriguing world of permafrost and the potential threat it poses as a carbon bomb. In this video, we'll explore what permafrost is, how it serves as a storage medium for carbon, and the significant implications of its thawing. From the release of methane gases to the risks posed to infrastructure and ancient microbes, we'll cover it all. Join us as we unravel the science behind this pressing issue and discuss mitigation strategies for a changing climate. 1. What is permafrost? Permafrost is a fascinating geological phenomenon, consisting of ground that remains frozen for at least 2 consecutive years. This icy terrain is predominantly found in the polar regions and high-altitude areas, where the temperatures are consistently low enough to maintain its frozen state. Covering about 24% of the northern hemisphere's land surface, permafrost is a critical component of our planet's ecological system. Imagine walking on a layer of Earth that is perpetually cold and hardened like a rock, yet beneath it lies a rich tapestry of organic matter. This hidden world, largely unseen by the human eye, plays a significant role in the Earth's climate dynamics. 2. Carbon storage. Beneath the frozen crust of permafrost lies a massive reservoir of organic carbon, about 1,500 billion tons to be precise. To put this into perspective, this is nearly double the amount of carbon currently found in the Earth's atmosphere. The permafrost acts as a natural freezer, preserving ancient plant and animal matter that has been stored away for thousands of years. This carbon storage is crucial in maintaining the balance of the planet's carbon cycle. However, it also poses a looming threat if released. Like a treasure trove with a hidden trap, the carbon locked within permafrost has the potential to alter global climate patterns significantly if unleashed. 3. Methane potential. While carbon dioxide, CO2, is a well-known greenhouse gas, methane, CH4, is another potent player in the climate change equation. As permafrost thaws, it releases both CO2 and methane into the atmosphere. Methane, though less talked about, has over 25 times the warming potential of CO2 over a 100-year period. Picture it as an invisible balloon expanding rapidly with heat and energy, capable of intensifying the greenhouse effect. This makes the thawing permafrost a ticking time bomb, with the potential to exacerbate global warming at a much faster rate. 4. The carbon bomb concept. The term, carbon bomb, conjures images of explosive power and urgency, and rightly so. It refers to the sudden, large-scale release of greenhouse gases from thawing permafrost. This scenario could accelerate global warming significantly, creating feedback loops that amplify the situation further. Imagine a domino effect, where one event triggers another in a relentless cycle. The carbon bomb is not just a theoretical threat, it is a plausible reality if permafrost continues to thaw at current rates. Its impact could be as profound and far-reaching as an actual explosion, with consequences for ecosystems and human societies alike. 5. Thawing rates. The rate at which permafrost is thawing is alarmingly unprecedented, driven largely by rising global temperatures. Studies estimate that if emissions continue unabated, about 69% of near-surface permafrost could thaw by 2100. This scenario is akin to watching an ice sculpture melt away under the relentless heat of the sun, with each drip contributing to a larger pool of water. The thawing rates are a clear indication of the pressing need for climate action. Without intervention, the permafrost will continue to release its stored carbon, further fueling the cycle of global warming. 6. Abrupt thaw events. In certain areas, permafrost does not melt gradually but rather experiences abrupt thaw events. These events can cause rapid melting of permafrost layers, releasing significant quantities of greenhouse gases in a short period. Imagine a dam bursting open, unleashing a torrent of water that floods the landscape. Abrupt thaw events have a similar effect, with the potential to release large amounts of greenhouse gases suddenly and unpredictably. This unpredictability makes it challenging to manage and mitigate the impacts of permafrost thaw. 7. Feedback loop dynamics. The dynamics of feedback loops in the context of thawing permafrost are both intricate and concerning. As permafrost releases greenhouse gases, these gases contribute to further warming, which in turn leads to more thawing. It's a vicious cycle, much like a snowball rolling down a hill, gathering speed and size as it goes. Once initiated, this feedback loop is difficult to stop, making it a formidable challenge in the fight against climate change. The self-perpetuating nature of these dynamics underscores the urgency for immediate and effective action. 8. Infrastructure risks. The thawing of permafrost poses significant risks to infrastructure in Arctic regions. As the ground loses its solidity, roads, buildings, and pipelines become undermined, leading to structural damage. Imagine trying to build a house on a foundation of sand, unstable and unreliable. This creates economic and social challenges for communities living in these areas, as the cost of repairing and maintaining infrastructure becomes increasingly burdensome. The risks extend beyond mere inconvenience, threatening the livelihoods and safety of those who call these regions home. 9. Ancient microbes and diseases. Thawing permafrost may also release ancient pathogens that have been trapped in the ice for millennia. These ancient microbes and diseases pose potential health risks to humans and wildlife, similar to opening a time capsule that contains unknown and potentially dangerous elements. The release of these pathogens could have unforeseen consequences, challenging modern medicine and public health systems. It's a reminder that the impacts of climate change can be as unpredictable as they are profound, affecting not only the environment but also human health. 10. Mitigation and monitoring. Mitigating the impacts of permafrost thaw requires a concerted global effort to reduce emissions. By curbing the release of greenhouse gases, we can slow the rate of permafrost thaw and its associated risks. Additionally, satellites and ground monitoring systems are crucial tools for scientists to track changes in permafrost and predict future impacts. These technologies act as sentinels, keeping watch over the frozen landscapes and providing valuable data to inform policy and action. Monitoring is not just about observation but also about preparation, equipping us with the knowledge needed to face the challenges ahead.